All right. Good, there they come. All right, so I'm just a few minutes before we start the lecture, but I wanted to talk about these events, of course. BSide starts tomorrow. And in the past, it's been free. I'm not quite sure. I think somebody told me it cost something this time, but I think you can still get in by volunteering and such. But anyway, that's my favorite convention around here, I think. It's a small convention, and it's all technical. There's no marketing, salespeople, vendors' booths, or any of that stuff. If you want all that, that's at RSA. RSA is like, let's make a deal. Fill the Moscone Center with guys handing out free T-shirts and thumb drives. And until I think last year, they would be full of women in bikinis posing in front of routers to get you to buy them and stuff. And finally, the anti-sexism people finally got through to them. You idiot, you can't be doing this. I'm amazed. It's against federal law, for crying out loud. Among many other possible objections, finally the pressure mounted to where they knocked it off. And they don't have booth babes anymore. At least that's what I've been told. But anyway, so it's hard to get in and expensive though, but there's a free day Thursday. Someone told me you could still sign up for the free student day on Thursday. And if not, you can always get free expo tickets by just Googling free expo tickets, because the vendors get a certain number of passes and they never manage to use them all. So vendors will often just give you a pass to get in the expo. But to get in the expensive trainings, you can't get in there easily. Anyway, so, but BSides has a bunch of events. The schedule's up. I'm giving a couple hands-on workshops. You guys have probably seen enough of my stuff, but there's a lot of other things happening there too. And anyway, so check that stuff out. It's all worth extra credit. And if you want to do it, you'll see what I'm going to give them for a show. I've got the first one ready here. I'll probably add a few more challenges to it, but I'm next one ready tomorrow. I'm just giving them a CTF consisting of your homework. So, you know, these are just projects from 124, and they automatically grade, and there's a scoreboard and all that jazz to make it into a CTF. That's all. So, you know, and then I just go around and help people do that. So that turns out to be fun, you know, it's the point. All right, so that's the future. Let's see, we're up to 10:08. Let me see if there's anything else worth mentioning about the news. This one is pretty interesting, actually. And might be room for another one or two. Yeah, that's probably enough for a couple of minutes I got for news here. So I've known for a long time, and I've been in the mobile device hacking class. Android is amazingly unsafe, and one of the main problems with Android is that Google does not control the update process, and they don't even have a security update channel. And they're learning the hard way, just like Microsoft did, that you can't trust carriers. See, the problem is Google puts all kinds of new exciting features in the updates, and the carrier's already charging money for those features. So they block the updates. So you won't get the free version of the same thing from Google. And so they block all the updates, including the security updates. So most people are using Android phones that are 2 years or more behind on their updates, which is insane. And so Google has been talking for years about developing a security update channel, which will push security updates through and promise not to add new features in that channel. So hopefully they'll get to the people with the handsets. But the handset manufacturers mostly don't go along with it, and I don't think it's really happening. And so unless you got a higher end phone, your phone never gets its updates. But this is a new one. I did not know this. They will now just lie about the update level. So it is not as obvious that you're 2 years out of updates. They will just change this date periodically without putting down the updates. So you think you're getting the updates, which, you know, anyway, that's what these guys say. I haven't checked any of this. I haven't had an Android phone in a while, except the emulators I use to attack. Just like Windows, I regard it primarily as a target operating system. Although, if you get a high-end phone, it's often pretty good. And there are a lot of security features in Android. The problem is, if you don't have the latest version, you don't have any of that. Anyway, so this was actually very interesting. Of course, Zuckerberg had to testify before Congress because they're all mad about the Russian hacking, and they're mad about the endless nonsense of Facebook security settings. But then Zuckerberg had a crib sheet of carefully written answers from lawyers to use, and he very carefully dodged the elephant in the room. See, what Congress people he managed to deflect them into thinking that what matters is the data you put on your Facebook wall. And that the privacy issue is whether the stuff you put on your Facebook wall is being shared with too many other people. And that is what Facebook wants the argument to stay on, because that is completely unimportant and of no value to them. And if they lock all that down, it doesn't matter. What Facebook really does is put tracking cookies all over the web and record everywhere everyone goes, whether you're a Facebook user or not, whether you're logged in or not, whether you're using their browser or not. And that's how they make their real money. But their opinion has been careful from lawyers. From their point of view, that is not your data. Your data is the text you wrote and put on your wall. That is like technically generated IP address data, which you didn't have anything to do with from their point of view, and they don't have to even call it your data. So you need these careful statements saying, yes, we inform users about what we do with their data. We have a link so users can download their data and see it. We have privacy settings for the user's data, because the real data that makes all their money, they don't count it as the user's data. And one of the congressmen tried to nail it down on that, and he managed to weasel out of it, is what I've heard. So it's very interesting, and this is what I always see. There's a technical problem with social importance. This is like the Snowden revelations. All of us in the business knew it 5 years ago, that the NSA was spying on everything. We knew it because Joe Klein leaked out the fiber optic splitter at 2500 California Street that the NSA was using to copy the entire backbone of the internet and the telephone network. He dug out the schematics of where they put in the splitter to make the illegal copy of it all. Everybody in the business knew, but it didn't matter until it reached public visibility in some form of these PowerPoint files people could understand. So here's the same thing. What's really going on, we all know, the technicians know, but the public face of it is weird and strangely distorted. Like, I'm watching strange things, like another gigantic victory for the right wing is somehow the left-wing energy is now about getting guns out of schools. And that's a fine thing, but it's really a very small issue. There's no way it's ever going to happen because they can't repeal the Second Amendment. So all they're going to do is ban bump stocks or something. And all the people that could be marching against something that actually matters, like the tax laws or something, are deflected into this side issue. It's interesting to watch. How you can.
I talked to one of the lawyers the other day. He said, well, yeah, but your ISP is even worse. They know everything. Now, without that net neutrality, they have no functions.
Yes, your ISP knows everything, but they're very inefficient at using it. They've been selling, your ISP does not put ads on the page, and I don't know why. Local television stations put ads on top of national TV. ISPs don't do that, and they should. It would make money for them. Comcast should be putting ads on every page. But for some reason, they don't. They even saw companies started manufacturing the hardware to do that 5 years ago and selling it to ISPs. Here's the equipment that will sit in the middle and replace the ads with the ads you put in. And they just don't do it because I think they're not competent enough to keep your account organized and get the tracking data. Google does it. But see, here's the next thing, which is why, maybe it's all right. It probably should not be stopped or regulated. If they did, the internet wouldn't be free anymore. They got to make money somehow. So it's just like a lot of these political things, people have completely missed the point, gone off on a tangent, and maybe it's better for them to harmlessly waste their energy over there instead of actually doing stupid things at the real point. I don't know. Anyway, so let's get on to the chapter here. All right, so we're down to hacking web servers, and this is a whole class in itself. I'm teaching this semester web application security. It is really important. This is the main area where people get bug bounties, although I must say bug bounties are pretty much a pig in a poke. I've been doing this for years. I've never earned more than a few $100 of bug bounties. Many people are very, very frustrated. If you actually want to make real money, get a job. Bug bounties are probably not going to make any money for you. If you can actually earn a significant amount of money at bug bounties, I'm sure you can get a lot more at a job. Anyway, it's not a real productive way to make money. The good thing about bug bounties, however, is the Pentagon setting the example of offering bug bounties, and Google and Microsoft and Facebook and Twitter has changed the culture to where more companies now understand that when you get an email from some crazy angry hacker calling you stupid and saying I hacked into your stuff, don't just freak out and lie and lock them in prison, but maybe actually read the message, because that is in fact how you find out important things. And that's what they need to get to. I mean, they hopefully will raise the culture to where they have more productive responses when you do inform people of security vulnerabilities. Anyway, so web applications are the big one. So here's what we're all living in, right? You have a browser down here, like IE or Firefox or Chrome or something, and you're sending requests up to a web server. Now, the web server is a sort of file server, but it's actually a much more strange, complicated beast, and it's using HTTP, or these days, more often HTTPS, to send encrypted data up to the server, and it sends encrypted data back. And that's what you're actually doing when you browse the web. So there are a lot of different web server software products out there. Apache was the #1 for a long time because it's free. The name comes from not the Indian nation, that's a joke. The name comes from the fact that it's a bunch of patches thrown together. In the same spirit, they really ought to call Windows Frankenstein because it's the product of many companies just sewn together. But anyway, Microsoft's product is here, and Microsoft is now #1, IIS. And Google's product way down here, Nginx, has come up from past 10%. Nginx is a special product designed by criminals to run botnets. And this is fairly common these days. If you have, starting about 5 to 6 years ago, it turned out that criminals had gigantic networks of controlled computers, far larger than any legal network, as you can imagine. And so they'd actually have, 10 million devices in a network, in a cluster working together, and nobody can afford that many. The biggest known server cluster I know of is 60,000 at 1&1. Google might be a little bigger, but the number is not public. So they have management consoles, and that's why the early botnets controlled their zombies with IRC, and IRC couldn't scale well enough. Yeah?
So if I'm understanding correctly, you're saying Nginx was originally developed for command and control networks?
Yes, this is what I've heard. Nginx, that's why Nginx for years was famous for being extremely efficient, extremely fast. What Nginx is Apache, where you throw away 90% of it to get down to just the essential core to make it faster, because Apache can't handle a huge server cluster and a lot of requests per second, but Nginx can. It cannot. Apache cannot handle as many requests per second on the same hardware as Nginx. Nginx is supposedly much more efficient, like 10 times faster, and that's why it's begun growing, although the big growth came when they finally began to write some documentation. Nginx originally, there was no documentation except in Russian, because it was designed by the Russian criminals to run their botnets of stolen computers. And people said, this thing is so good, we should make it legal. And, so anyway, it's growing.
Is it open source?
What's that?
Is it open source?
Yes, it's open source, and the documentation is now out there, and it's growing. It's now reasonably easy to install and run, and it's a lot like Apache, but just very much simpler. Yes.
Oh, absolutely.
Yeah, it's being used for lots of legitimate stuff. It's actually now down above 10, more than 10% of the web is coming from Nginx. If you really want to get the most out of your hardware, you use Nginx. Now, the reason why Microsoft is growing more and more popular, of course, is that if you have a large company, you pretty much have to have a Windows domain controller, because you can't handle a normal business product like having a partnership or a buyout or a sellout to another company or anything without Microsoft Active Directory. And once you have Microsoft Active Directory controlling your network, you really want to use Microsoft's version of everything. Life will be much, much easier if you use Microsoft Instant Messenger, Microsoft Email, Microsoft Web Server, and Microsoft everything, because it'll all fit into that Microsoft ecosystem. So this just is, that's why someone would use IIS. And the general rule is a large company uses Microsoft everything, a small company uses open source stuff like Apache. There are a few exceptions, highly technical companies that really want everything to be fast and really want to be able to customize all their software. They use open source everything, even though they're big. But that means they have a team of real experts to keep up with it, like Cloudflare. I mean, everything is open source because they got to be fast, fast, fast. They're delivering like more than 10% of the entire web to people. It's all about speed. Anybody with really high demands pretty much goes to open source. Everybody where high performance computing is not their #1 goal finds it cheaper to just use Microsoft stuff because it has all the features you need to run a normal business. And most people really don't care if you have to pay a little more to get faster hardware because it's less efficient. What really matters is management efficiency for the company. Can we easily find staff that know how to use it and train people and partners and such. So just using a standard thing is worth a little more, paying for a little more hardware. So the web applications are running on the server, and you're sending requests up to it like Gmail and such. And the problem is, of course, everything has bugs. We've talked about this. And if your web application has a bug, it's exposed to the whole world. Everybody can attack it. And everybody's putting data on your system. So pretty soon you've got customers stealing each other's data and breaches, stealing thousands or millions of credit card numbers and all that jazz. Now, in the early days, web pages were just static. You would just deliver things like broadcast TV. There'd just be a picture and some prices or something, and that's fine. But nobody wants that kind of page anymore. Now they want dynamic pages where you can put in customer numbers and credit card numbers and buy things. And so you have scripting languages on the service. These things are called CGI scripts. And if you use Microsoft stuff, you use Active Server Page. If you're using open source, you typically use PHP. And there's a lot of other scripting languages and other languages like database connectivity languages used. So when you just go to like Amazon and buy something, you're using many servers all working together with many different languages and technologies connecting them. And that is why it is so dangerous. And there's so many problems because it's like you send your message up and it gets translated into French and then into Japanese and then German. And then people ask, why did it get misunderstood? Because it passes through many systems, each of which garble it to some extent. So and the simplest element to start with all is a form tag in HTML, which lets you make a structure so you can type in things like usernames and passwords and credit card numbers and submit it, and then it will send it up to the server. So you have a form like this. Here's a form I used years ago where you would just type in a comment about the class and it would go on my page. Then what happened is people started filling it with spam links to going places. So I put in an anti-spam feature, which consisted of a horse. You had to type in the word horse, and it never changed. I didn't have any other pictures or anything, but that was enough to stop the automated attacks for several years. And this is, small security barriers are not useless. You have to have a threat model. If you're trying to stop people that don't know much, a 3-foot fence will stop them. And that's all I cared about. So this form I wrote in Perl a long time ago, and I didn't know much. Perl is a really old-fashioned way to do this. So it lives up here on in my server. You can't normally see the source code. Here's the source code of my web page. You've got this thing to select what class you're in, and then you've got this place where you put up images. And I changed the name of the image to mystery.jpg, so you couldn't just have a bot take the name of the file and put that in for the answer, and that's all. But it was always just a horse. And so this set it up to the server. All right, up on your server, CGI accepts the data that comes up from the server in a form and then processes it. And there are a lot of languages. In the old days, you do it with Perl. You could even use C or C++ or Visual Basic or Fortran, or even write a Unix shell script that would run in SH or Bash, which is a pretty bad idea, but it could be done. All right, but anyway, so here's a simple example. Here's a Perl script that just prints out a hello, the hello world Perl script. There's really not much to it. And so here's the Perl for that feedback form. So it's got, you cannot normally see the source code for a server script. And this is one of the large issues. People get so used to that they casually put secrets in the source code and assume nobody will see it. And that's not a good idea because very often there are defects in various parts of the system that make it possible to see the source code. But anyway, so your parameters come from the HTML form. And so at the start, you're going to find some statements like this that retrieve those parameters. One parameter is named class, one is named comments, one is named animal. So I fetch them from the incoming request and I put them in local variables, $class, $comment, and $animal. Now, if the animal is not equal to horse, then I'll print error. Your comments are not recorded because they appear to be spam. Otherwise, I'll print the header and say thanks, and then I'll define the name of the file. Notice I got the name of the file from a parameter. This is a common mistake beginners made, and I made it back then. I didn't want to always have the file go to the same place. So I put the file in a hidden field on the form so it would go up to the server. But that means a smart hacker can change this and write the results somewhere else. And this is how you deface pages and hijack them and stuff. That would print data out to the file, which came from the user. And this is the, you see this with almost every PHP-based site. Within a year or two, they get hacked because if you write PHP, even though you know better, and in the course of normal events, pretty soon it turns out that there is some file being written that contains data that came from the user, and somehow the name of that file also came from the user. And now you can just use your page to write over files they shouldn't be writing to. This happens all the bloody time. Anyway, so ASP is Microsoft's technology to do the same thing. Looks a little different, but accomplishes the same thing. Running on a Microsoft server, of course, uses JScript or VBScript. Typically, you're only using Microsoft browsers, although I suppose you can use other browsers now. Once again, you can't see the source code, so if you make an ASP example here that just shows the time, you can't see the source code, but if you look at the source code, it's HTML, and inside the HTML, it's got these less than % signs. So this is what PHP does also. It mixes two languages in the same file, which long ago, 15 years ago, Microsoft did this with Word documents, and everybody screamed, "You fool, we shouldn't do that. What's wrong with you? Putting two different programming languages in the same file is just evil. Of course, we're all getting hacked." And now everyone's just given up and gotten used to it. The way the web is, everything's all mixed together. So this is nuts, but you put in these HTML-looking tags that are not HTML, so the HTML parser goes through the file, and it finds this less than %. It says, "What is that garbage?" It says, "Well, I dare not say that is an invalid tag and stop, because for all I know, I am an old browser, and this is a new version of HTML. Maybe there's a tag like that." So whenever an HTML parser finds a tag it doesn't understand, it just ignores it and keeps going, which is another recipe for disaster. You know, if you want secure programming, you ought to be like Fortran and C. The parser goes through and it stops. Missing semicolon, blap, I give up, I die. I will not touch this filth until you clean it up. I'm not going to do any more of it. This is unacceptable. But the web browsers are not allowed to do that because it has no idea what you're doing. And you can add optional components to the server, which cause strange things to now mean something to another parser that's going to make another pass through the same file, hunting for whatever it wants. So your web browser, "This looks horrible, but maybe it's fine. What do I know?" And so nobody, and the other parser doesn't know everything either. So none of them can actually tell that your file is full of horrible stuff. Anyway, that's the way it works. Apache was the most popular, and my slide's out of date, not for the last couple of years. IIS is now the most popular. But anyway, you can run it on Windows or Linux, although it's usually run on Linux, and you use it in some of the projects. Then you can have scripting languages. JavaScript and PHP are by far the most common. Microsoft's VBScript seems to be fading away, but it is still used. All right, so PHP originally stood for personal homepage and was intended to make it easy for people to personalize their pages. And then, like Unix, they decided that is not confusing enough, so we have to make a recursive acronym to show off how cool we are. And so now PHP stands for PHP Hypertext Processor, so the P stands for nothing. And if you're into Unix or symbolic logic, this is really a lot of fun. But anyway, so the rest of us this is a clue, like GNU. GNU stands for GNU's not Unix. The G stands for nothing, just to poke you and say, "Ha, you're stupid, you don't know symbolic logic, yeah. Anyway, hey there. So, all right, so you've got PHP here. You put this, starting with this question mark PHP tag and ending question mark there, and you mix the PHP into your HTML file, just like the last one. So here I've got an HTML file with a title, and down here I've got a PHP script that prints out something, and then I go back to HTML again. Of course, this is pretty dangerous, and you've been hacking it. The main vulnerability you see from PHP is local file inclusion, and when you combine it with a database like SQL, you get SQL injection, which we've been exploiting. ColdFusion is a proprietary one from Alaire, which is now Macromedia. It's expensive, so I've never used it, but it's popular for people who get involved in that proprietary language. And once again, you mix two languages in the same file. You got HTML and you have these CF tags indicating to the poor HTML processor that once again, this is some bizarre thing it doesn't know about, but the ColdFusion parser will find these tags and take action on them. And like every other thing, it's got its flood of vulnerabilities running by, so it's got cross-site scripting and information disclosure and security bypasses and everything else. And so, like I say, you have to update your stuff, and it is really appalling that Android stuff is not updated. And VBScript was Microsoft's attempt to compete with JavaScript by making their own. Microsoft's always been fond of BASIC and Visual Basic. That was the main technical thing that founder of Microsoft did, Bill Gates. He wrote a BASIC parser long, long ago. Anyway, so you can put VBasic tags in your file, and they will be executed by the browser, and they look, again, you have script tags, which are a little more polite in that they have an actual HTML tag to tell the parser to ignore it, and then what language it is, and you have commands in here. But on you go. So as always, it's got its series of vulnerabilities in the VBScript language, just like the others. And then there's JavaScript, which is by far the most popular. Everyone gets used to it. And of course, in the modern world, JavaScript has really taken over in the form of modern frameworks. And almost everything is using advanced JavaScript. And that's because about 5 years ago, Firefox, Mozilla started saying, why is JavaScript so slow? They looked at the JavaScript parsers in use at that time and said, these things are just really poorly written. And they wrote JavaScript to make it 100 times faster. So suddenly it was possible to do all sorts of advanced things in JavaScript. And for a few years, Chrome and Firefox could see a bunch of pages and you couldn't play them at all in Internet Explorer because this thing was too slow. This competition pressured Microsoft into improving their processing of JavaScript also. And now we have these heavy JavaScript based frameworks. JavaScript is now the new hotness for web development. I've had a lot of people mock me for my web page because I'm not using any of that modern stuff. I'm way behind. My stuff is from like 10 years old design features, and they're quite correct. They say, why aren't you using cool new Node.js and everything? Well, because I don't know any of that. But I got to catch up on these days. Anyway, because there are a bunch of hacking contests now, and there are new vulnerabilities caused by that. If you use Angular or Node.js, there are configuration files that can lead you to the secret files that have the secrets in them. And I've seen a few CTFs about that. So I'll have to at least learn how to break these things pretty soon. So here's JavaScript. Once again, you have HTML, you got script inside it, and here's the thing that will pop up, tell you to click a button and then get mad at you if you do click the button, and so on. You just this alert tag we use a lot as a simple JavaScript tag that you can see the results of to test whether JavaScript can be injected. Do that in the Crosssite scripting. And JavaScript has its vulnerabilities, of course, like everything else. So there's lots and lots of programming languages, and I thought it's sort of fun to see how popular they are. This is from a couple years ago, but you see Java and C are always big. Python is always really big. JavaScript and PHP and Visual Basic are big. So, you know, you ought to know at least one programming language if you're going to be any kind of computing professional. If you don't know any language at all, you've never learned any, the one to start with is Python. Python is easiest and very powerful. Java and C are much more difficult because they're structured and compiled. Python can be run interpreted, but those are your next step. Here, I think they encourage people to start with Java, which in my opinion is cruelty. I think that is too hard. I think they should start with JavaScript or Python and then move to Java or C++, but they did not ask me. Anyway, all right, so I got some of these Kahoots. And they are supposedly ready to go in one of these tabs. There we go. All right, this is 10A. All right. And yes, there we go. There we go. Do you want to do the eval after this? Okay, good. I've got to get a piece of paper. All right, got another few seconds to see if any more are coming. Apparently so. All right, that's good. If you're succeeding in injecting code into the Kahoot and getting points, it's definitely worth extra credit. All right. All right, so which one is Microsoft's web server? All right, that's IIS, good. And when it ends that fast, it means everybody answered that fast. It would have waited 20 seconds if there was anybody still thinking about it. What's the most popular web server? This one changes every few years. It's now IIS. It used to be Apache. All right. And which one of these is not programming? HTML is not a programming language. It's just a markup language. It's not MP complete. It doesn't have variables. It doesn't have loops. All you can do is describe how things look. All right. What language uses less than question mark? All right. That's PHP. All right. And what's the most popular programming language? I'm pretty sure it's C. Let's go back here. Was it C or Java? Java above C. Okay, good. Thank you. Good. Okay. All right. Good. All right. Good. So it's Java. Good. Well, that's good. Then the CS department is apparently correct in that regard, putting Java on top. All right. So Steele, they're going to have to tell me who you are. Okay, good. That's who I figured it would be. Okay. And M. I know who that is. And Alert will have to tell me who they are. Is Alert here? Ah, good. Okay. So, all right. You're Danny, right? Okay. And you're John, right? Good, good. All right. So I got these points. Well, let me step out and let Abigail take over. She's got a form for you folks to fill out. I'll be in the hallway for that. This is a contractual requirement. Oh, I might as well pause the recording. This particular part is probably not going to be of any interest to the people there. I'll be back in maybe 10 minutes. Let me pause. Is this pause the whole thing? I had an expert out there. That's quite good. Last time I managed to pause just part of it. Screen sharing. No, how do I pause the whole thing? That's just screen sharing, but it still has sound. Pause recording. Recording. Okay. Fair enough. So people say they can't get the VM to boot from an ISO for Project 13. So let me see. There's a way to do it, which I thought was no longer necessary, but maybe it is, where you adjust the VMX file. Yeah, okay. I'm going to demonstrate this. If you go to, okay, it's going to look a little bit different on a Windows machine, but the underlying structure of the virtual machine is the same. So somewhere is my Windows Server machine. Well, I'm losing, here it is, fair. There's my Windows Server machine. All right, so let me show you this. If you go here, here's what a Windows machine, here's what a virtual machine looks like. There's a series of files. These are the disk files. Those are the memory files. And someplace in here, there is a VMX file. This is the file that controls the machine. And if you can't get it to boot from a CD, you need to get into the BIOS. And you can't get into the BIOS on a Windows machine because it boots too fast. And you can't click and press F2. So what you have to do is give yourself more time. So you open this with a text editor, like Notepad on Windows or whatever you've got on the Mac. And this file is what actually controls everything about the virtual machine. And you add one line to this file, and the line is bios.bootdelay. Equals 5,000. You have to be careful and not foul it up. But that's the line that makes it take longer to boot up, so you have time to get into the BIOS. This is the general solution. And I used to have it in the project. I took it out because I thought you did not need this anymore. But from what people are saying, you do need it. And if you do that, Now, when it boots up, it will give you some time. So this thing keeps popping up and it won't go away. We restart this thing. Okay, restart now. That would be fine. Probably trying to shove Windows 10 updates or whatever. Probably. Updating orchestrator service. Yeah, that's Microsoft for you. Anyway, when it does boot, it will now give you enough time to click in there and press F2. So that's what you have to do. And I can help people do that in the lab. There may be some other solution. For some reason, I thought it was not necessary anymore, but from what complaints I'm hearing, apparently it is. All right. So anyway, yeah. All right. Let's go back to here. And all right. So anyway, so let's talk about the database part, which we didn't get to before. So you have a client down here in the browser filling in a form and then sending data with HTTP or HTTPS, which goes to Apache. And then if you need to buy a product or something or log in, it needs to get to a database. So it has to send data over the network to a database server. And if you have a properly configured network, you will have traffic control configured on your routers. So you cannot go directly from the internet to the database server because it's too high value a target. You force them to come through the web server, and only the web server is allowed to talk to the database server. And that's why attackers in pen testing have to pivot. First, they take over this box, then they install attack tools on the server and use them to attack the other servers. Anyway, so that's what has to happen. And to get over to this server, which is handing out data, it's running some product like SQL Server. So it gets requests over the network and then sends data over the network. And that's sent by one of these languages like ODBC or these other technologies that do the same thing. So these are just ways to package data and send them over the network so a request for data can get to the database server and the response can get back. The old-fashioned way was open database connectivity, and this can go across many different products. All right, and I see that the mute is not working as usual. The mute all doesn't work, and all the features that get something off the screen don't work, but other than that, Zoom is pretty good. Anyway, all right, there are some newer products, OLADB and ADO, which are attempts to update ODBC, but accomplish doing about the same thing. And so there are a lot of vulnerabilities here, as we've seen. All right, so if people do manage to compromise your web server, then they can, of course, steal the data stored on it and on the associated databases, deface the website, and they can then use it as a pivot point to attack other servers on the network. OWASP is the organization focusing specifically on this part of security. It's an open source group. People join, and every company has members in it. They have meetings. I occasionally hear that there's a San Francisco OWASP chapter that's having meetings again. It seems to flare in and out of existence. The San Jose chapter is really active. Anyway, these guys have a lot of projects. They give you a lot of analysis of web application vulnerabilities, and they give you a lot of libraries of secure code you can use and integrate into your database. They publish the top 10, and this is the latest version of the top 10 from last year. So this is probably the most famous thing OWASP does. Everybody has to learn the top 10. So number one has always been SQL injection. It's never been anything else. It is the most dangerous vulnerability in the world, although I must say I think unsecured Amazon databases are beginning to give it a run for its money. But until maybe the last 2 years ago, when people started finding all the unsecured Amazon databases, there was never anything to ever come close to the damage of SQL injection, because people are just stealing records by the millions, by the hundreds of millions of SQL injection all the time. And it adds up to more damage than everything else put together. So then there's broken authentication, where you find there's the credentials that people send up are handled improperly so that it is possible to get into other people's sessions or steal tokens. Exposing data down here is the kind of thing I was talking about at Amazon, which I think is probably going to move higher the next time this goes up, where people put data up on the web and it's not properly secured, so unauthorized people can find it. XML external entity, we're playing with this in the 129S class. This is a way to do code injection on XML-based sites. You can define an external entity which will fetch an active object from another server and add it to your XML page, and then you can refer to it in data inside XML tags and run it. So it's a little funnier looking, but it ends up being a little bit like SQL injection or other code injection attacks. Then there's broken access control. Even if you correctly identify users, many websites fail to actually check the identity of people before allowing them access. They have something like unsecured direct object access is quite common, where they have a page and there's no actual check to see who's accessing the page. They just assume that nobody will find the page except the authorized user. There's a lot of ways to misconfigure your server. Here's where they put those open S3 buckets right now. And cross-site scripting we played with, where one user can put script on something that runs in another user's browser. Deserialization is quite an issue. If you want to move a lot of data to the server, this is common on Java pages, but it's also used by SAML. If you want to move a lot of data, you often combine it into one blob and put it in something like base64, and it just turns out to be fairly common that developers look at that confusing stuff and believe that it cannot be modified. And they don't understand that it can't easily be unpacked and modified and repacked. Unless it actually contains a signature and you actually verify the signature, the fact that it's serialized doesn't mean that you can trust it. Yeah. Okay, anyway, that's the problem with almost all these rely on trusting data that came from the user when you shouldn't be trusting it. Anyway, components with known vulnerabilities is, of course, a big one. This was the 2014 disaster on the open internet of Heartbleed. Was the most famous example recently of this, where some library used by many people has a flaw, and therefore tons of products all have a flaw. This happens over and over again. And insufficient logging and monitoring is new, I think, and I'm glad to see it. This is the people have begun realizing that for defense in depth, you must have logging and monitoring in addition to your other defenses. Until recently, people pretended that preventive measures would stop attacks. Now they accept that no matter what you do, some attacks will get through, and you have to have another layer of defense responding to those. Yeah?
What's the difference between XSS and CSRF?
Okay, cross-site scripting is injecting script tags in a page that run in another browser. Cross-site request forgery is somehow tricking someone into executing a request that they didn't approve. So there are two common examples of cross-site request forgery are using another browser tab. Like you put something on something like a Facebook page that causes someone to go buy an Amazon book. So it'll work if they have an Amazon tab open. So the script from one page runs on a different page. And another form of CSRF is where you steal a cookie and get in somebody else's account. So these are, something from one page is run on another page. That's the cross-site part. But cross-site scripting does not necessarily involve impersonating someone, and request forgery does. But they're closely related. All right, yeah.
How much does this change year over year?
I think they change it every 3 years. And when they do, it usually changes only in small ways. 7 or 8 of them stay the same. Number 1 never moves. They shuffle it around a little bit. If you learn one of these from a few years back, it's pretty much the same message.
So we need to add it or remove it.
Yeah, sometimes they combine them.
It doesn't change a lot.
It does not change a lot, because web improvements happen very slowly. Now, in longer time periods, like decades, there have been major change. For example, Microsoft in 2002 made a huge change in their policy toward security, and it began really having effect around 2008. So before maybe 2005, most attacks compromised the operating system. Now, you can't really compromise the operating system very easily anymore at all, so most attacks target something else, like the web server software, or more often the extensions in the browser. So over decades, the vulnerable spot does shift, but not over just a few years. All right, so here's Java serialization. So you get an example. So you have some structure here that's going to have a customer name, a business name, a contract ID, and then some passwords. And that whole thing is going to be serialized by Java into a thing, which is then just a long blob of text. And a person might think that that thing is no longer a security risk to make it visible to the viewer, but it is, of course, because just serializing it does not hide it. it obscures it, obfuscates it by putting in something like base64 encoding, but it doesn't necessarily encrypt it or sign it. Anyway, that's what serialization is, and you can play with that a lot with burp. You can open up serialized objects, modify them, and reserialize them, unless they are encrypted or signed, which is what they should be, but they often aren't by default. So cross-site scripting is where script tags added into a page affect other users, and we got a few of these. I think you've seen this before. Just for concreteness, let me bring this up. This is the classic cross-site scripting stuff. All right, so here, if I've got a page where I have a message, and when I click this, it puts that message on the page. And this is very common if you have a search engine. I search for boxes, it says, here's the result for boxes. If it puts something that came from me on the page, then the question is, do they filter it? So one simple test is try italic and see if they filter that, and you see those turn into italics. So this proves that either the developer is very smart and they let you use a few harmless tags, or they are very stupid and they let you do anything you want. And in this case, it's unfiltered, so you can put in, this is what people usually do. As a classic test, they put in a script tag with a pop-up box in it. And if you do that in Chrome, it doesn't work because Chrome is getting fed up with this. And what's happening is the browser manufacturers are beginning to compensate for the insecurity of the web developers. This is also happening to some extent for SQL injection and a lot for insecure authentication over HTTP. The web has a lot of legacy stuff that will never be fixed, but the browsers can compensate. So Chrome won't let you do this anymore. So let's try it in Firefox. Firefox will, however. So let me bring up my Firefox, and I'm actually running my Firefox through burp, which is not necessary for this demonstration, but I might as well just leave my Firefox that way because it's handier for the other class. So burp is the proxy in the middle, so you can see the requests go by. If I go here to attack, all right, and I have to bring burp to the front to make it respond quickly. Oh, the proxy is intercepting. Okay, there we are. All right, so now cross-site scripting. All right, so if I put in that same script here and make it as big as possible, all right. Now I get a pop-up box reflected. This is what you typically do just to prove you can run a script. And the point is, if you can do that, you can pop up boxes containing secrets like cookies, and you can even send them to remote servers. So that's bad. All right. And I've got, so you notice that's called reflected SSS, where I have, so here, when you click this, it pops up that box. Now here, it's going to pop up a cookie, and the cookie is secret value, so it can pop up in a box, and I could just as well send it to another place. And here's another thing you can do is open a pop-up window in a script, so it loads content from another page. And that's the typical thing. Here's something that will actually send the cookie up to a remote log. I've written a script called posttext called PHP, and that will actually send that cookie up to a remote log, or supposedly. Looks like maybe it's not going to work. Let's see if clear log file works. See if something good happens now. And it looks like that one's not working. I'm not going to struggle with it. Anyway, or maybe it's just burp being slow. Let's see. Oh, it is burp being slow. Okay. Do that. Yep. Okay, there. It sent that cookie up to the remote server. So that's what you do. You configure a server to take requests and you send it up. And if I get a cookie, I can typically just get in your account, because many people now, what you're supposed to do is add anti-CSRF tokens to your web page so that a cookie stolen from one machine and put in another machine will not work. But many developers don't. They should, but they don't. And that means once someone's got your cookie, they're in your account essentially forever. All right. So you can steal someone's cookie. That gets you in their account if the developer did not put anti-CSRF tokens. You can harvest stored passwords from the browser, redirect the web page, and so on. If there's another browser vulnerability, you can sometimes compromise the operating system of the machine that's browsing, although those get patched pretty fast. So when you're trying to find these things on a web page, look for dynamic content, look for a back-end database server, figure out how authentication happens. How do they determine who users are? How do they determine what authorization they get? You will often find that something unsafe and approximate is being done there. So static web pages do prevent a lot of attacks, but there are still some attacks that work anyway. An old one in IS was directory traversal. You could just surf from the URL of the page back up into sensitive system files. And this still happens occasionally, most commonly with PHP. One way to prevent it is to filter out the .. If you open a normal web page, let's see what I've got in Chrome. Let's go to City College. It's a pretty good place to demonstrate this. If I wander down here into the schedule and then somewhere, summer French, okay. The URL now is ccsu schedule summer French.shtml. I can go back up to schedule by putting .. here. And then it will go into summer and .. will go back up to schedule. And I am back at the schedule. So that's how it's operating as intended. But if I do more .. then I'll get up to the root of the server, C or something. Then I could look for like Windows System32 cmd.exe. And back in the days of Windows NT, you would now get a command prompt. You could just type in commands and execute them on the server. And this is why Linux people got this attitude that Windows people are idiots and everyone should just be using Linux to be secure. Now, they won't fall for this. That's been patched long ago. It was pretty embarrassing. That's directory traversal. And that particular kind of old-fashioned directory traversal hasn't worked in 10 or 20 years. But what works more these days is PHP file inclusion, which lets you do some of the same thing. Anyway, SQL injection, you can check for simple cases by just adding punctuation marks in the field. SQL looks like this. You've used it in the project. You select something from a table and named customer, where the username has a certain name and password has a certain name. This is typically how logins work. But if you put in this username, apostrophe or 1 = 1 .. then you select where username is blank or 1 = 1, and this starts a comment line, so the rest of the line is ignored. So the condition is always true. So the logic will proceed to whatever happens when this condition is true, which typically means you'll authenticate as the first user in the database, which is usually the administrator. So you've done this in Project 19, you've played with this, and hopefully seen it go. All right, so if you're going to test these things, you put in punctuation marks to see if you find a SQL syntax error. A syntax error is the kiss of death because it proves that you're able to change the syntax of the page, which means it misunderstands what you put in as commands instead of data. And that should never happen. And when that happens, you have a command injection vulnerability. All right. It is very common that you need to go to another server to get the credentials. You have a database server or a radius server or something that's actually holding the passwords. So the web server harvests them and it has to pass them over to some other device for verification. And so then the question is, how does it move inside the company? Until the Snowden revelations about 4 years ago, it was very common for companies to have the attitude that we do not need to encrypt traffic inside the company. All we need to do is encrypt the outward-facing traffic inside the company. There are only trusted people and trusted machines. And the security experts have been yelling for years, but your laptop might be infected. People might sneak in thumb drives and copy stuff. Hackers might sneak in web sniffers. There was something about 7 years ago at DEF CON, this guy made an attack that consisted of you take an iPhone, you put an extended battery so it'll run for about a week, and you mail it to a company with a sniffer running on it, and you just mail it to a non-existent person at the company. So it will go in the company, sit in the mailroom for a few days, then they'll figure out that there is no such person and return it back to you all full of data. And they were horrified. Oh my God, they could get everything. We would never know that happened. We don't log the mail that's undelivered. We don't even open it, of course, we just send it back. And they were actually sending data over unencrypted wireless inside the company. And then when Snowden came out, it became clear that the NSA had been doing this to American companies all along. They'd been treating them as adversaries. They had a sniffer inside Yahoo, sniffing the internal network because They use plain text between their own devices. So all you have to do is add a rogue device inside the network and you get everything. You don't even have to decrypt it. And now, so people finally started encrypting their internal traffic. And that's what you should do here. The traffic from your database server to your web server should be encrypted, because you should not imagine that that is a trusted zone. It probably isn't. Anyway, so generally there are two ways to go. One is your Microsoft, so you use Microsoft everything. IIS, web server, ASP programming, and SQL Server database. That's the big people do it all that way because they need the fancy features that Microsoft gives you. The other companies use open source everything, which is Linux, Apache, MySQL, and PHP. Need some?
How about
Nginx would be like Apache. Would be in the second case. Yeah, you wouldn't use Nginx on Windows. I've never seen anybody do that. You'd use it on a Linux shop. Yep. And yeah.
Just along the whole, using internal Wi-Fi, or it could be a situation where a company has several floors in one building. Well, the Wi-Fi does not magically stop
Yes.
at the floor boundary. Someone who is downstairs or someone who is out in the lobby.
Absolutely. I mean, it's amazing, but you know, the vulnerability of WEP was found in 2010, and it was continued to be approved by PCI compliance through 2010. And the largest hack of stolen credit cards in the world was done by stealing credit cards over WEP protected network. And then the FBI let that guy Gonzalez be an informant, and they let him out of jail, and he did another hack, which was again the largest one in the world, again the same way, by cracking into WEP networks. It is just amazing how much companies do something that everyone knows is unsafe. They just keep it up until you force them to stop. It's I know. Well, they're trying to run a business, and the security people are always screaming about stuff. You just get tired of listening to them. Whatever you do, they always whine, so you just fire them until you get someone that won't whine so much, and you keep going. I kind of understand it. This is why if you are a security person at a company, it is necessary for you to develop some good judgment and figure out what battles to fight. If you try to fix everything, they will just get fed up with listening to you. You have to somehow decide what are the 2 or 3 most important things to deal with here, and develop a relationship with management to where you can actually get them fixed. And if you get a CISSP, which is the credential you need for this, they talk over and over again about how you cannot have a security program from the bottom up. If you must first convince someone at the top level of management to care. If you don't have a champion at the top level of management, you need to just give up or go to another company. You will never be able to implement anything important in the world of security without top level buy-in, so they were actually willing to spend money and resources to improve security. And really, in practice, the only way that happens is they get hacked. They have to get hacked and get hurt a few times until somebody at the top of management decides, you know, we better start caring about security around here. But there's always people at the bottom screaming and yelling about security problems, and that doesn't work. You need to start from the top. Anyway, you'll see that in several versions on the CISSP exam. Anyway, so you do footprinting to find your platform, which is pretty easy, and Nmap scan will tell you. And if you want SQL injections, they're all over the place. People run scanners, and they find them so many, they just dump them by the thousands on Pastebin. You can just go to Pastebin, and there's just vulnerable websites out there all over the world, pasted all the time. I've used to troll through here and then warn people about it. Here's another bunch of them. Here's one of them I went and looked at. I just put an apostrophe at the end of the URL, and down here I have, you have an error in your SQL syntax. So Vortex Ignition's car parts has SQL injection vulnerability, and the whole world knows. Here's a Burp Suite workshop with another one, I think. This is I think this one is a file inclusion vulnerability. I see it's got a file name here, and I think you can, yeah, that's the one. This is why, what I mentioned about file inclusion, PHP often looks like this. You have a PHP file, and then you have a parameter, and the parameter is a file name. This is the way people often write PHP code. And if the developer doesn't think about this, you can take that file name and point it somewhere you shouldn't be, like etc password, and there's the password file. Now, the password file, contrary to its name, is not a secret. The reason you use it is it's world readable. It doesn't contain passwords. It hasn't contained passwords since the 70s. Because that's what these X's are, where the password used to be. The password's in another file. But the point of this file is it means I'm able to see files that I should not be able to see. Nothing should be visible to the web server except the contents of the var www.html directory, or wherever your web home is. But this PHP file is letting you traverse through the file system and see files outside there. Yeah.
Is it only visible where the file is world readable?
Yes, largely. What happens is you have a certain identity, and typically, if you're using Apache, your identity is www data, not root. And so then you'd only be able to see the files that are visible to that identity. But if you can see files at all, you can move forward. This is the art of pen testing and exploit development, is improving your access. Now, you have some degree of access. Now, the next thing is if you can upload a file, you can upload a PHP file and get a PHP shell. And once you have a shell, you can look for a privilege escalation exploit. And that's what you do. This is the first step. This is information disclosure, but that's often enough to move you up to the next step. You often have to find a series of vulns to really get all the way into a system. Anyway, so there's a whole document here from OWASP telling you how to check your web application, and it's very extensive. Use a search engine to see if they're leaking their data on the web somewhere, someplace like Pastebin, fingerprint the web server, enumerate the applications on the web server and the path and so on. This goes on and on for pages. There are just many things that can go wrong, and that's what a real thorough security audit would be. There's some more examples, checking file extensions, HTTP methods, and on it goes. Many, many things to check here. Check for an unenforced username policy and so on. Just all the things that can go wrong. Sending credentials over an unencrypted channel, allowing people to do file includes, traversing to directories they shouldn't be in. You know, there are many, many things that can go wrong. And session management and cookie handling, testing for cross-site request forgery, you know, it can really be quite a job to try all these things. All right, and then there's input validation. Here's testing for SQL injection. And it's not just MySQL, all databases, including Mongo and Oracle and everything, are vulnerable to these injection attacks if you do not take measures to prevent it. All right, there's the business logic testing. Even aside from all the technical errors, there are just errors like taking process timing, leaking out data. We've done that in the web hacking class. Often you can tell whether you have something right by the time it takes to process it. So you can deduce information that ought to be secret. And you can often run functions more times than you should, and so on. There's many other ways to go wrong. And then there's the client. The user can have any variety of things wrong on the client. Clickjacking is one of the more pretty ones to see. Clickjacking is where you have a page that says click here to buy something or get your free product, and there's another invisible page on top. So when you click, you're actually clicking a form you can't see. And you can have people type like a sentence, and you can pick words out of what they type and type it in another invisible field, so they're spelling out a command that they don't know they're spelling out, which are clickjacking attacks, where the data they put in is being redirected to another invisible window, and they can't see it. All right, anyway, so you look for tools to get in, and there's different tools depending on the vulnerability. Fundamental tools you always use are Firefox and Chrome, and they're developer tools. These let you see the exact requests and responses that built the current page, and you can manipulate pages here too. That's a good place to get started. If you're a developer writing pages, that's often as far as you go to see how the resource is loaded. If you want to start manipulating them, you use a real proxy, and the one hackers prefer is Burp. What I'm using here. In Burp, you can see every request and response. So this one here I've been using. If you just go to HTTP history, you can see all the requests that have been used here. Now, I just did some kind of injection attack here a while ago, so I should be able to see that here. Here's viewing the posted credentials that were sent up to another server. So it sent a request, and then the response is here, showing me 200 OK, and there's the secret value that was sent up to the server. So the Burp just lets you see everything, and it lets you modify it, and it has automated scripts to try to break in by trying every combination of letters in different fields to try to guess the password and such. It's got a whole series of tabs and We're doing a lot of that in 129S. Anyway, Nikto is a special vuln scanner just for websites. This will look for known vulnerabilities on a server like phpMyAdmin and such. One good thing about Nikto is it runs pretty fast. It only takes 5 or 10 minutes to run on a server as opposed to things like Nessus that can take many hours. It's not very thorough. It just gets the big flaws, like if you have phpMyAdmin available, which is a well-known administration console. Something people like to do to spare their programmers needing to know anything about websites is they put on a graphical environment where you can, like WordPress, where you can just click on this to put up a post and all that. And that's fine, except those frameworks are often configured in default locations with default passwords and foolish vulnerabilities like that. It was true of this college. This college moved to a web content management system about 4 years ago with our new website, and the students in my CISSP class did a security audit, and they found that there were features on there that had the default password. They were able to figure out, get in. They weren't able to actually deface the website or anything, but they were able to see stuff they shouldn't have been able to see. It commonly happens. So Nessus, I mentioned. Nessus lets you do thorough scans for vulnerabilities. It's the most popular vulnerability scanner in the world. There's a free version called OpenVAS, but the Nessus version has, I think, a free, somewhat limited version for educational use. And so I think you'll use it in the projects. Scan your server and you find a series of vulnerabilities on it. And then one really important thing about vulnerability scanners is they will find a bunch of critical vulnerabilities and you have to go back and test them by hand every time. If you hand this to the client, you are harming them because vuln scanners are very inaccurate. They miss a lot of vulns and they very often freak out about things that don't really matter. So you have to manually investigate the vulnerability to see if it is real, and you have to make an intelligent judgment about whether it matters. It might just be that technically some unexpected action can occur, but in fact, that action will not lead to anything important. You cannot really buy a product or get into someone else's account there because some other control stops it. And that's why clients pay you for a pen test, is to evaluate what really matters. Don't just give me some kind of automated report telling me there's 100 problems. Figure out which problems are actually going to hurt me. That's what they're paying for, that human judgment. W3AF is an open source scanner. Some people love it. I find it crashes a lot. It crashes more often than it works for me. I managed to break my own SQL injection vulnerable page, and it picked up the SQL injections pretty well at one time. This Nessus, I think, is far more popular, but there are dozens of vulnerability scanners out there, and this is one of the other options. Then there's a lot of commercial tools. Skipfish is one that Google put out. I haven't heard much about it in recent years. The main thing about Skipfish is that it will find every page, which is what you might expect. It's clearly based on Google's crawler. And the thing about Google is they can find every page. That's their main interest, but this will also find some vulnerabilities. And all right, got a few cahoots about that. And good. Looks like we're doing fine on time. There'll be a Hackers Club meeting at noon, so we'll be out of the way for that. 10B. All right. All right. All right. Looks like that's it. Okay. So what phones let an attacker see private files? Okay, that's local file inclusion has that property. All right. Which one lets the attacker steal the contents of the database? All right, that's SQL injection. All right. What phone lets one user attack other users? All right, that's cross-site scripting. All right. And what's the vuln scanner that's not free? Nessus is not free, that's right. All right. So I've got Pedro and M dot again, and WGA, I know who that is. All right. And all right, now one thing occurs to me. I'm getting a little confused because the other classes, have we been through the SQL injection stuff in this class or not? Maybe not in this class. Have we talked about this? Maybe not. All right, then let me just do it now because that's, it's a good demonstration. I do it in so many classes that I get confused. So if you haven't, all right, so at first, databases confuse people. People are used to single flat files like Excel. But a database is what companies use for a real business problem because they have tables that are more complicated. They have a table of purchases and a table of customers. And one customer might make many purchases. And one purchase might be canceled, but the customer as a whole is not canceled. So you need multiple tables to reflect the complexity of a real business situation. So here's a very simple database that somebody else made with these silly names in it, and I just used it. And this, so I have a table called users. Let me blow that up as much as I can. All right, users, this is a very simple case. There's username, and this field tells me whether they're an administrator or not. 1 is the admin, 0 is not an admin. That's called the users. Then there's a table called SSN, and that has users and social security numbers. And that's it for my database. But the point of this is just to show you how two tables can be connected and how we have sensitive data in the tables. So normally the way you use a database is with SQL select queries. Select queries remove data from the database, and the select star will get all the data there is from a table by the name of the database and the name of the table. It's the SQL database and the users table. So when you submit, you get all the results in that table, which is usernames and isadmin, a numerical field. So if you let the user type in a select query, they can do anything. So this is something you'd only let your administrators do. You would not let a customer type in a raw query because they can do anything. For example, I can just change that N to SSN, and then I'll get every customer's social security number. And that might be okay for my administrators, but I certainly don't want normal users to be able to do that. So you can have a where clause where you limit it. So if I want to show someone their profile, like HERP, I would want to only select the information for this one person where name equals HERP derper. And when I submit that, I now get the results for only that one person. So this clause found where the name field matched this name, and the problem is it parses this. And what happens, this is active, select, this is active, this is just data. And if I put in a name with an apostrophe, like O'Neill, here, which is entirely possible. Somebody might have a name like that. Now I get a syntax error because the apostrophe I put in here matched the apostrophe the developer put in here, causing it to incorrectly parse this. So it figures out that's the name, and now it has this word Neil, which ought to be a command. And so this means I'm able to inject a name, and part of that name is treated as a command. That's why you should never see a syntax error. All you should be able to see is I found it or I didn't find it. You should never see a syntax error. It should never be confused about the difference between data and commands by anything that comes from the user. That's the syntax I should not be able to break. So let's go. You can actually write to a file on my server, because one thing a select command can do is write. So if I do this, I'm going to put it in temp test, what is today, April 14, 414. I have to use a file that doesn't already exist because I can't overwrite an existing file. But this is going to put that text, literal text, into that out file, temp test 414. And it didn't find any results, but it did not give me an error message. So it worked. So to see that file, I have to go to the name of the server and then get rid of the folder and put in temp and then test 414.htm. Okay, there's the literal text I put up. So I can now deface the website by adding extra pages. I can't change existing pages, but I can add new pages. This means I can get a shell. So we'll do that in a minute. Here's reading a file, by the way. I can load a file off the website. So I can read this file called test1 with a load file command. I guess I'll do test 414. That's the one I know that's up there. I just put it up there. And it doesn't matter what the table name is there, but it has to be a table that exists so it won't crash. This will now load the contents of that file and put it here. Here's the literal text. So now I have file writing capability and file reading capability from being able to execute arbitrary select queries. So SQL is a language that can read files and write files, and if I'm able to put in my own queries, I can do any of those things. Now, I would not normally give a user a field and let them type in this stuff, but what I am going to give users all the time is fields like this, login fields and shopping fields. So here you can put in a name and just search for that user. This is a common feature. So if I search for herpderper, I find herpderper. If I search for a wildcard like %, I'm going to find everybody. And that's by design. There is a wildcard in SQL if you want to use it. But if I search for a name with an apostrophe in it, then I get a syntax error. And like I say, this should never happen. This is the kiss of death. That means that was the name and it interpreted this as a command. So when you have an error that crashes the server, that's a denial of service, and the process of exploit development is improving that to do something more interesting, like remote code execution. And that's what we're going to do. So now we have denial of service. To get to remote code execution, we just have to write a more intelligent query, like this one. Now, if you don't know anything about the database, like you might, if you go to a real website, all you have is some field for logging in or searching for things. You can't get any data out of a database unless you know the name of the field and the name of the table you're trying to take data from. But what you can do is you can target tables that are automatically created by the management software itself. And if it's MySQL, what it does is it automatically creates this thing called table schema, which is in the information schema. And that is what it uses to store the structure of all the tables in a database. So if I put in this long string that has 4 apostrophes in it and use that for a name, then you get SQL injection here. It found the name of all the databases. And the reason it did is because I fed in this mess as the name. But the server misunderstood that by mismatching these apostrophes. So a username like nothing. Now union is a valid SQL command that lets you add a second select query to a first select query and combine the results. So now I'm able to inject a whole select query where I was only supposed to be able to put in a name. And the new query goes to table schema from information schema tables. And this part at the end where A equals A is just to use up the remaining apostrophe without causing a syntax error. And this condition is always true. So it'll now take all the data it can find from information schema tables and print it out here, and it'll show me that I have a database named SQLOL. So that's the first step. That shows me the names of databases. Now I'm going to find the tables in that database with a similar long injection. This one shows me the name of the tables, which is SSN and users. And the reason it does is because that long name is, again, misunderstood as the ending of a name here at the first apostrophe, and then another select query. And this just gets table names from information schema tables. So I now have the table named SSN to target. So now that I know the table name, I need to know the columns, and you can get that with this one. And their columns are named name and SSN. And again, I injected this long mess. This time, I didn't bother having the where at the end. Instead, I think I ended with a comment character, which is common, Control E, there. No, I table scheme, I just put out a hanging apostrophe there. That's fine. You can do that as long as it matches. Anyway, that gets me the columns. So now that I know that the database I want is SQLOL, the table is SSN, and the fields are name and SSN, I can now tell it to dump out all the SSNs. And this is what automated attack tools like Havij, which you're going to use in the projects, do. They just automatically do all this. They have a series of these prepared statements and they try versions of it and they get into simple cases. So this is how people steal large databases. This is how Anonymous stole data from Sony and many other companies and from an FBI group and so on. So this is why it's so dangerous. You don't need any special tools. You don't need any special skill. All you need is to practice some standard attacks or run a standard attack tool. Many people do this without even understanding what they're doing. They run Havij, Havij gets the data, they're done. They don't even really know what SQL injection is. All right, but when I put this thing up in an earlier version, somebody hacked it and they managed to do things I didn't think he should be able to do, that I had not intended for him to do. And I said, how did you do it? And he said, you're so smart, figure it out. So I had through 2 cycles of him mocking me further and me increasing my logging until I've learned how to use Apache forensic logging, which lets you log every query that comes in. And I learned about PHP shells, which is a trick I did not know before. And here's how it works. You've seen that I can write to a file. Now I can write to a file with any name I want as long as the name hasn't been used, and I can put any text in that file. So I put in this stuff. Now I have to choose a file name that hasn't been used before. So again, I'm going to just put the date here, shell 414. Okay. So what this is going to do is it's going to write this text right here between those quotes into a file name. This is PHP script. It's a very simple PHP script, starting with a less than question mark PHP, ending with a greater than question mark greater than at the end, and some PHP code in the middle. It's going to put it in this file, temp shell14.php. So I submit that. I didn't find any results, but I did not get an error message. So there's now that shell. So let's view that page. Shell 414 instead of test 414, shell 414, and it's PHP, not HTML. So now I get an error message, and the reason I get an error message is my PHP code is this here. It's trying to execute a system command in the variable called CMD. I have to provide the CMD. I have to put it up here, question mark, it's a parameter, CMD equals LS. Now it executes LS on the server. And if you want it to look prettier, you view it with page source there. So now this is the result of an LS. So I can now execute any command I want on the server right here. So if I want to know, there was a question earlier, you can only do world readable files. Now I have the ability to execute commands on the server, but I'm not root. So let me make this fit on the page better. All right, let's try putting in a semicolon, who am I? And after the LS, it's going to show me who I am, which is www data, which is the name Apache runs under, and it's not a high privileged account. So I can do some things like write into the temp folder, and I can read from certain files, but there's some things I can't do. I can do a date and so on. A date will execute down here. So we're doing this a lot more in the other class, but now I have escalated a denial of service to command injection. I can now execute arbitrary commands on the server. I'm not root yet. The next step would be privilege escalation. And then I could take over this device, then the next step is pivoting. I put tools on this device and start attacking the other devices on the network from this one. And that's how penetration testing works. So that's, I think, as far as we go in project 19. Let me take a look and see. Yeah, so here, I have a few challenges for you to do here. By the way, to fix this problem, There are two levels of fixes. The simplest fix is to just escape special characters. In this form, if I put in Mike O'Neill and submit it, it just looks for a name called Mike O'Neill and doesn't find it. It does not give me a syntax error because this one line here called my real escape string adds backslashes before the quotes. So that will break the simplest form of SQL injection. However, it doesn't protect you from numeric SQL injection, where you inject into a numeric field because you don't need a quote in that case. So there is a better solution where you actually use parameterized queries that define the data object in another way so it cannot be misunderstood as a code object. And that is completely impenetrable. There is no way to do injection anymore there as far as anybody knows. So you've got a few challenges here, which you can do by working through those. And then there's some extra credit ones here to try. Anyway, so there's some extra credit projects where you actually fix this database so it's not as vulnerable. But it's kind of a drag to set it up. Anyway, that's SQL injection. You should know the basics of it. And that's what I wanted to show you. You got any questions? I'm just going to knock it off and clean up. And I'll go, I guess we're going to have a Hacker Club meeting, and I'll go up to the lab after that and see what's going on and teach 127 after this. Okay, so let me end this and